yesterday is sort of a overview kind of day. It gets everybody on the same page in the same context. Today, we're going to dive right in to some technical work. And we've got a treat. Sud is with us from Esri's product team. He runs the product team. Sud has been with Esri for 30 years. So those of you that ran ArcInfo Grid, it's all his fault. ArcView, the designer of the geodatabase. And now he's sort of running the whole show. So Sud's going to share some words about Esri's product development philosophy in the context of science. Take it away,
great.
Sud. Thanks.
Thank you, Drew. Thank you. So ArcGIS is continuously advancing, right? It's factoring in innovations in computing, innovations in data, and innovations in GIS itself. And as we do this, we're informed by your science and your needs, and we hope that the work that we do is helping you as you work on solving the challenging problems that we face in the world today. So thank you for being here, and wanted to just give a brief overview to the work that you're going to hear in a lot more detail. And it's really focused on analytics, right? So you heard from Jack yesterday. He talked about the whole platform. I thought I'd drill a little bit into the analytic aspect. And in talking about analysis, you have to talk about data. One of the things that's been really unique, I think, about GIS is that it integrates all of the aspects, all three aspects of information processing, right? Sometimes we call it the system of record, the geodatabase, all of the various kinds of data, of course, the analytics and processes that you run against it, and then the dissemination of that information. All of those come together in GIS, but at its heart, analysis works against data, and as you know, ArcGIS supports a very large variety of data, and our goal is to build integrated analytics against all of that. And in the area of spatial analytics and data science, we really have a set of offerings. And it's available, this capability, both as an analysis and data science workstation. That's how we like to think about this aspect of ArcGIS Pro or ArcMap, ArcGIS Desktop. It's really a workstation for analysis and data science, and also an analysis and data science platform. That is, it's available in ArcGIS Enterprise and ArcGIS Online, right? It's a key aspect of WebGIS. And our goals there are a comprehensive functionality, convenient user experiences, scripting and notebooks, that's Python, that's R, and of course, powerful analytic engines and servers that work against all of that data in an integrated way, because like we know, data doesn't live in silos, and it's not just one type of data that we need to analyze. We need to bring all of that together. So, when we talk about, really rich functionality, actually a good way to illustrate that is by talking about our workstation offering. That's really, I'll use Pro as the example. It's a wealth of analytic functionality that works against data. It includes both algorithmic things, what we call geoprocessing, as well as, statistical techniques that you apply to data. So we have comprehensive tabular and vector geoprocessing tools. We have the model builder and ArcPy that you may be familiar with. We have tools for raster analysis, 3D, for network analysis, solving logistic problems, of course, spatial statistics and pattern mining, a lot in the area of image analysis and raster analysis, multidimensional data analysis, and of course, the geostatistical analyst focusing on geostatistics and interpolation and kriging and prediction. And all of this integrated into a user experience. So one way to think about ArcGIS Pro is that it's almost this complete integration of an analytic engine with a user experience with no gap between them, right? You can run Pro on a powerful desktop. You can spin it up and run it on a machine in the cloud with lots of cores. It can connect to diverse data, and it's all there at your fingertips, all dedicated to you, the person using it. And it includes user experiences, it includes Python within it, with the recent advances in the integration of Python into Pro, lots of additional libraries. So it's really a powerful data science workstation. And then, of course, we have the spatial analysis and data science platform. And that is really ArcGIS Enterprise and ArcGIS Online. I don't have a slide here that talks about all of its aspects, but like it includes web-based user experiences for accessing the functionality. It also includes APIs, and it also includes access via Python to really drive those engines. And we've been thinking hard about that, and we're bringing functionality into that platform in these analysis services and engines. And we continue to work on that. And we are leading in that area with ArcGIS Enterprise, but we're also working on bringing all of those things to ArcGIS Online. One of the areas that we've been working on is big data spatial analytics, working on large tabular and vector data sets, working on large raster data sets. And these are really encapsulated in our geoanalytics server and in our raster analytics server, which is basically our image server extensions to ArcGIS Enterprise. And the focus there has been leveraging distributed computing and parallel processing to process data faster. So geoanalytics has focused on a variety of problems, including some of the foundational geometric and tabular processing that people want to do on big vector data sets, but also the enrichment of observational data from other contextual geospatial data, and then also the application of statistical machine learning to that data in a big data environment, right? So that includes things like the enrichment of data, but then the analysis of that data in terms of clustering, in terms of classification, in terms of prediction. So that's really our goal there with that server. Raster analytics has really been, it's the continued evolution of what started with grid, became spatial analyst in ArcMap, is spatial analyst in ArcGIS Pro. It's that spatial analyst that's now available running in a server context, taking advantage of distributed compute to really work on very large problems against sharded data that's managed in this enterprise and in this cloud environment. And we've been focusing on both image processing algorithms as well as the raster GIS algorithms, right? So it includes the local functions, the global functions, the focal functions. All of those are really in this function chain context, and it is very powerful in executing these models. And the parallelization work has been on all aspects of it, including global functions like the hydrology functions, which compute things like flow accumulation, so using iterative algorithms. So that's an area of focus. Wanted to say a few words about machine learning and spatial data science. It's empirical analysis of data, and this is has a lot of traction in the world today. It's a lot of this work is being done. Our contributions to it are geospatial algorithms. In all of these areas that you see listed here, for example, clustering, a variety of density-based clustering algorithms, as well as spatially constrained multivariate clustering, but of course also standard multivariate clustering in this environment, like for example, k-means. So bringing all of those techniques together in this environment to work with geospatial data, similarly in the area of prediction. And then ArcGIS also integrates with these external machine learning frameworks. So really Python is an excellent environment for this, right? We have ArcPy for driving the core engine that's inside ArcGIS Pro. We have the ArcGIS API for Python. That drives these engines that are available in ArcGIS Enterprise and ArcGIS Online. I talked about those big data engines. They all come with REST APIs, but the way to drive them really is through Python It's there at your fingertips, even though it's running in that server environment. And the really interesting thing is you can drive analysis, which executes on those servers against the co-located data. You can also pull data from those data stores into Python and process it using additional Python libraries that you add to that environment. And that includes the wealth of scientific analysis that's available in Python. It also includes all of the developments in machine learning and deep learning that are available today. We see a lot of use of this in many areas, including the obvious ones like image analysis and object detection from imagery and so forth, but also in the area of general data analysis. So I went on for quite some length about Python, and this is the slide I should have actually had up when I was talking about it, but this just shows the ability to drive these server-based engines through that API and notebooks. And these are all areas that are there today and that we continue to work on integrating into the platform even more. So as we look ahead to next year, we really see the addition of hosted Python notebooks to our WebGIS as a foundational expansion of that model. So we have layers, we have maps, now we will have notebooks too, and the ability to work with all that content that's within your WebGIS through these notebooks. And then finally, one of the questions that comes up is, how do we select the analytic functions that we choose to build, and what do I do if the particular function that I need is not there? And ArcGIS is also a strong developer platform. As you know, it supports access to that data. The formats that it works with are open. That data can be extracted from those stores in a variety of representations. These includes things like point clouds, meshes, rasters, tile packages. All of those specifications are available. And then we have all of the APIs that give you access to our engines, including the Python API, the ArcGIS runtime APIs, the JavaScript API, and the ability to extend Pro. And these give you the opportunity to extend this platform with additional tools as well as applications that really shape it to your needs. We hear from you that your use of GIS spans a whole range of aspects of your workflows, all the way from data acquisition to dissemination of your results to other citizen scientists who may consume that, and to policymakers. And like we said, GIS sort of does have these different aspects that lend to that. We're very interested in hearing from you, and I'll leave you with that. Thank you.